In this video, I'm going to be looking at another question, and this question is also in line with the equations of motion of a body moving in a horizontal circle. That is, when a body moves in a constant circular motion with a constant speed. Now, a disk has an initial angular speed of velocity of 10 pi radian per second. You can see that in this, and that it has an angular acceleration it maintains this constant angular acceleration of minus 2 pi radian per second squared. Now, how many turns are rotated by the disk in 8 seconds? Okay, one thing you need to know about this, I think I've said this in the last video when I was talking about angular velocity and angular acceleration, that when you have a disk, a body like this moving in a circular path, let's say it's rotating along the axis, along this line through the center of the disk. Now, if it rotates in this direction, we call this anti-clockwise, that's the direction of the angular velocity. That the angular acceleration is also in the same direction as the direction of what? The angular velocity. Both are in the same direction. That is to say, if the disk is speeding up, because when the two parameters, the two quantities are in the same direction, it means that this disk is, rotating with increasing angular velocity. But if both are in opposite direction, let's say this is the case again, the body rotating along the axis through its center. Now, suppose the body is still rotating in this direction. That's the direction of the angular velocity. And the angular acceleration is in a direction opposite to that. This is a case when the body is slowing down. This is a case of deceleration. Just like in linear motion, when the direction of the acceleration is opposite to the direction of motion, the body starts decelerating, that is slowing down. So that is what applies here. So if both are in the same direction, it means the body is moving with increasing angular velocity. But in opposite direction, it means the body is slowing down. You can see this concept plays out here in this question. Now you are given a negative angular acceleration. That shows that this is a type of deceleration. The disk is now slowing down, just like a rotating fan, and then you suddenly turn off the switch. It starts slowing down. Deceleration sets in. So, but how many turns will it rotate? How many times will it turn over in 8 seconds? But first of all, since this is a case of the disk slowing down, what's the time taken for it to get to or come to rest? We need to find the time taken for the decelerating disk to come to rest. Let's call that t, unknown. Now recall that when it comes to rest, the final angular velocity is 0. The initial angular velocity remains 10 pi, is given in that question, radian per second, and we are given the angular acceleration as minus 2 pi radian per second squared. So we look for one of the equations, that has all these parameters stated in this question, the facts provided about the question. I think we'll go with the first equation, omega equals omega naught plus or minus this angular. Now this is my 0. That gives me what? 10 pi plus minus 2 pi times t. So that gives me 10 pi minus 2 pi t. All right, so when I collect like terms, I have 2 pi t equals 10 pi. Of course, negative will cancel out negative when this comes to the other side. So pi cancels pi. So I have my 2t. Pi cancels pi. My 2t equals 10. It means the time t equals 5 seconds, which means it takes 5 seconds for this rotating disk to slow down and then come to rest. But how many times would it have turned? What is the number of revolutions completed in 5 seconds? We can use the second equation of motion. I can call that theta 1. Theta 1 is omega naught t plus half alpha t squared. Should use this. Let me find the number of revolutions completed, or the angular displacement covered rather. Let's find that first. So theta y 10 pi, it was given, multiplied by 5 seconds, 10 pi plus, that will give me half times, this gives me minus 2 pi. Of course, you know that it was negative, times 5 squared. Okay, I'm going to have this as equal to 50 pi, 5 times 10. This is now negative. These two cancel out this. That gives me 25 pi left. So what is left is 25 pi. Okay, so this gives me the total angular displacement described by the disk that is slowing down. Now I can find the number of revolutions completed. Let's call that N1. N1 is given by theta 1 divided by 2 pi. Okay, that gives me 25 pi divided by what? 2 pi. Pi cancels pi. So number of revolutions completed is 12.5. Okay, of course, you know that has no units. Now, that's not all. This is just in 5 seconds. Come back to the question. The question says the number of revolutions, number of turns rotated in 8 seconds. So there are extra 3 seconds. It means that it takes 5 seconds for this body to come to rest. And when it comes to rest, we expect it to go back, that is, begin rotating again. Of course, maybe in the opposite direction this time around. All right, so it rotates again for another 3 seconds. Okay? This time around, we'll take the acceleration as positive. A change in direction, probably. A change in direction of the body. 2 pi, now positive. So I'm going to use one of the equations of motion to find the angular displacement. This time around, it starts, because since it comes to rest, before it started the second part of the rotation, we need to give this 0. That is, the initial angular velocity becomes 0. All right, so I'm going to find this. Let's call that theta 2. The total displacement covered or completed after 3 seconds. So I'm going to use the second equation of motion. And what is that second equation of motion again? Okay, let me move to a new page. That gives me theta, I call that theta to omega t plus half alpha t squared. So this gives, since it starts from rest, so what's my theta 2? That gives me half times 2 pi multiplied by 3 seconds squared. So this cancels this. So my theta 2 is 9 pi radian. Okay, we're assuming that after the body stops, it continues motion for the next 3 seconds. All right, so that the number of revolution now is theta divided by 2 pi. That is 9 pi divided by 2 pi. This gives me what? 2 pi. That gives me 4.5 revolutions. So that the total number of revolutions rotated is the sum of N1 and N2. The first one gave us, what is that again? 12.5. So I'm going to add that. 12.5 plus 4.5. That gives me 17. That's the total number of revolutions.